Welcome to the Your Innovation Coach webinar. Today's topic is Understanding Project Risk, Part 2. I want to go back to Part 1. At the beginning of that webinar, we talked about the three primary risks that we typically consider in new product development. Those include the overall risk to the business for the project, and it includes multiple factors. And then there are two other risks that we tend to deal with separately, though they, in my opinion, are really a subset of the overall risk of the business, and that's the technical risk and the schedule risk. So we typically deal with these three categories of risk in one of two ways. We attempt to manage that risk, to understand it, to cope with it, and we also try to mitigate it, to lessen it, to reduce it, maybe to eliminate specific risk factors in general. The other thing we talked about last time is the source of project risk really has to do with uncertainty. And we reviewed the three primary categories of uncertainty that lead to risk in new product development. One is the concept of task variation plus what we call foreseeable uncertainty, and then whatever's left over is residual risk. Task variation is simply when we create a schedule. It consists of a number of different tasks. Each of those tasks is really not a specific number. It's really a number plus or minus something. So for instance, we predict that it's going to take us 2 weeks to get something from a vendor. It's really 2 weeks plus or minus something. So that carries through in every task within the project. So that's task variation. Foreseeable uncertainty are things that we can anticipate and plan for. And so we use things like risk lists and FMEA and so forth to look at that type of uncertainty. And then whatever's left over is residual risk. This is really the category of uncertainty that most project managers understand how to deal with. And we use the common tools like Gantt charts and critical chain and risk lists and so forth to manage projects with this type of uncertainty. Secondly is complexity, and that has to do with the number of parts and how they interact. I used an example last time of an electromechanical system that has, say, multiple new subsystems, and then on top of that you might be adding all new software embedded and upper level. And since the software interacts with every subsystem, that can be a very complex system. And then finally, there's what's called unforeseeable uncertainty or unknown unknowns. These are things that we don't know. And that is the most difficult type of uncertainty that leads to really the highest risk type of projects. A key insight that I pointed out is that we tend to focus on the schedule and the technical risk for projects, but really these uncertainties can play out at a much higher level, at the level of the overall business risk. So for instance, even if you're working on a brand new business model, the risks associated with that business model may not have anything to do with the schedule or the technical issues. It may have things to do, for instance, with your knowledge of the market. There might be an uncertainty associated with that leads to risk in that development. So you really need to think more broadly when it comes to your projects in terms of not just focusing on the schedule and the technical risk, but where these uncertainties can play out in other aspects of your project. And I mentioned a good resource that you can look at if you want to learn more about this topic. So there were a number of tools that we talked about last time. I introduced you to the risk matrix. We'll come back to that today. We talked about some of these qualitative business risk tools, risk lists and so forth, as well as FMEA. I also introduced you to a quantitative business risk tool, the NPD Risk Assessor. But today I want to focus on these last two topics, and we'll talk first about managing and mitigating complexity and unknown unknowns. To start off this discussion, I want to go back to that risk matrix that I introduced you to last time. And as I mentioned last time, this is a really good place to start and to think about your project. So at the bottom here of this matrix are the sources of uncertainty that we talked about: the task variation, foreseeable events, unknown unknowns. and on the y-axis of the matrix is complexity, so low complexity to high complexity. And depending on where you are will really point you in the direction of the types of tools that you're going to use in order to manage the risk. So if your project is faced with strictly task variation and is low complexity, then your typical tools like Gantt charts and critical chain using project buffers and so forth work perfectly well. If on top of that you've got foreseeable uncertainty, then things like risk lists and FMEA are tools that you're going to use. I introduced you to the concept that on top of that, if you've got high complexity, really you have to have a mindset of control and fast response in terms of dealing with that type of risk. But really what we want to focus on right now is out here in this quadrant, and where you're faced with a lot of unknown unknowns as well as complexity. These types of tools that you might use down here just don't work out here. Now, last time I did introduce you to the concept of, we use iterate and learn and parallel trials or some combination of those two in order to deal with this type of uncertainty or risk in a project. And I want to dive in a little deeper to both of these topics. So as I mentioned, I introduced you to the two concepts last time. These are the graphics. I think it's pretty self-explanatory in terms of iterate and learn is a serial type of process in terms of learning, ferreting out these unknown unknowns, whereas parallel trials, you're learning with parallel types of sub-projects. But I'll mention here, and I'll come back to it here in a minute, that it's not an all or nothing type of proposition, that you can actually combine the two techniques. You don't have to use one in isolation of the other. So let's first talk about iterate and learn. And really, iterate and learn is fundamentally based on this age-old concept of the plan, do, check, act learning cycle. And so really, if you look at any of the lean methodologies, whether it's lean manufacturing concepts or scrum and software development, which I'm going to talk about here in a little bit, the lean startup movement, all of these types of things are really based around this concept of the plan, do, check, act learning cycle. And so this has really been around for many, many years. It gets repackaged and renamed different things, but it's fundamentally at the root of all of these lean type of methodologies. And it's really a learning effort, exercise to ferret out and unknown unknowns, to bring out this uncertainty and understand what you don't know, to learn as quickly as possible. So how it plays out in the context of new product development really is better illustrated here, where it's really all about designing experiments to maximize your learning. You have to set some boundaries for improvising during that experiment. You run that experiment, you learn from it, you look at the results, and you make improvements for the next experiment, and then you carry on in order to continue to learn. So there are some really key principles when using this process. First is you really need to look at it in terms of failure as a learning opportunity. That's what this is all about. Now that sometimes is very difficult depending on the culture within the organization, especially if you're very familiar with doing incremental development where you don't have a lot of unknown unknowns and uncertainty. This may not be a comfortable place to be. You have to build your organizational muscle around this concept of looking at failure as a learning opportunity. Secondly, you need to experiment as early as possible. This is the concept of fail fast and fail cheap. That's what it's all about. It's not important about what a prototype looks like and designing it to the nth degree. It's about what don't I know and how am I going to learn it just as quickly as possible. And to go along with that, you have to organize for frequent and rapid experimentation. Again, culturally, if the organization is not used to that, sometimes that is a difficult thing. We get very set in our ways. We get very process-driven. We want to have things lined out to the nth degree. That's not what this is all about. And so you have to have a little bit different mindset to make this work. And finally, you need to take advantage of all of the different experiment technologies that we have available to us today. from 3D printing to computer simulation that's now much more affordable and can be done really on a handheld device for all practical purposes. So there are a lot of things that we can do today to quickly experiment and learn that we didn't have available to us 10 years ago or 20 years ago. So you need to leverage those technologies and use them. So really how this kind of plays out in terms of project planning is that, from my experience, when we start a project, we usually have some type of basic design, maybe a block diagram to start off with. From that basic concept, we start to kind of lay out a really high-level schedule, probably driven by some of the high-level deliverables that come out of our phase development process. For instance, we know we need to do X number of cycles of prototypes. We know we have to do regulatory approval. So we have some really key milestones. We start to try to block out maybe on a high-level Gantt chart in terms of trying to lay out a basic schedule. So a schedule, revision one of a high-level schedule. And then from there, along with that and our basic concept of the design, we then probably are going to use things like FMEA and risk lists to start to pull apart the pieces of that project, going back to that risk matrix, and trying to understand what kind of uncertainty, what kind of risks we have with different pieces of the project. We can prioritize those risks based on those calculated numbers that we talked about last time. So we're going to start looking at things. Now, some of these risks may be very well understood, and we have a plan. It's easy to anticipate what we're going to do if we come up with those risks. So we might stop there. And again, this feeds back into the schedule and continues on as the project progresses. But we might take this, the outcome of this analysis, and now use things like our internal experts to really start to try to ferret out where are our knowledge gaps. We may come up with something in this analysis that points us in the direction that we really just don't know how to manage that, or what the root cause of that particular risk is. And so now that's going to point you in the direction of using some of these other techniques like iterate and learn, the learning cycles, or parallel trials, in order to learn as quickly as possible and really understand the root causes and how we're going to deal with those particular risks. And again, that feeds back into the schedule, and on it goes until we get to market. So as I mentioned, out of that analysis, you're likely going to identify some knowledge briefs. And so one way to operationalize this concept of iterate and learn is we can kind of incorporate a concept out of the Toyota lean manufacturing process, this concept of the knowledge brief, the A3 knowledge brief. And it's been adapted here to maybe give you some structure around how to actually implement the iterate and learn learning cycle. So the concept is you might have multiple of these knowledge briefs for the various different knowledge gaps that you're going to identify out of your risk analysis process. So for instance, let's take an example, maybe that you've got a particular circuit that you have to design. It's going to manifest itself maybe on a printed circuit board, on one or multiple printed circuit boards. Some type of a circuit that needs to be designed in order to get a certain particular performance characteristic. But you've identified that as a risk in the sense that you really don't know how you're going to create that design. So that's an uncertainty. It's an unknown unknown. You really don't know what that design is going to be. So that might be a knowledge gap. And so that's the theme of this particular knowledge gap. Somebody's going to own it, probably an engineer. And then you've got this brief that basically looks at the various aspects of that problem. You got the problem statement, right? You've got a design that you've got to come up with in order to get a particular performance characteristic, but you don't really know how you're going to do it. You're going to look at maybe different the problem in terms of what the root cause, and you might use some of your common tools to kind of ferret out the root causes of the problems, the 5 whys, the fishbone diagrams, et cetera, et cetera. Really, this constitutes the step one of this learning cycle in terms of planning. And then you got some goals, what it is that you're going to set for the goal for the experiments that you're going to run, and the alternatives. You might have 2 or 3 or 4 different alternative designs that you might want to attempt to try to evaluate. And at some point, you're going to, after you've run multiple experiments using these alternatives, one of those is going to have to be selected. So these kind of 3 blocks really have to do with the step 2, the do step of the learning cycle. And then you got to verify it. How do you test that your design is going to work for what you want it to do? So there's a verification step. That's really the check part of the learning cycle, and then finally you're going to implement and follow it up, and that's the step 4. So you can kind of use this concept of the knowledge brief to provide some structure around the use of iterate and learn. Okay, so the second concept that we use in ferreting out unknown unknowns is this concept of parallel trials. And again, this graphic shows what we're talking about here. You're running multiple experiments rather than doing these things in parallel. There are some key things that you have to consider. First, you have to define some space for the feasible and practical solutions. That becomes more important in parallel trials because you can't run an infinite number of trials. You're going to have to decide on how many you can really affordably run, and that's going to come back to understanding what the feasible space really is. You've got to be able to decide when to stop the experiments. They can't go on indefinitely, but you can't stop them too early, otherwise you won't really learn what you need to learn. And then you've got to make sure that you can really get the team to buy in to whichever solution is really the best. And we're really not necessarily after a 100% solution here. We're typically trying to just find something that's going to work, the 80% solution rather than necessarily the 100% solution. And then you've got to integrate that learning across the multiple projects. Now, there are some really key challenges with this technique. Obviously, it's much more resource intensive, so that's, I think, why you don't see it as much, particularly in small to mid-sized type organizations. It relies on a very strong project manager because you got a lot of moving parts when you're running parallel trials. And again, project manager has to be able to have open lines of communication across all the teams, and then there's more of a motivation effort in terms of most of the teams, all of the teams except one are not going to be selected as the solution. So you have to be able to motivate the teams of the non-selected solution. Now, as I mentioned, it's not an all or nothing combination. That's the point of this slide, that you can combine both techniques. Fact is, if you've got task variation and maybe only foreseeable uncertainty, then your traditional kind of tools are going to work, right? Your risk lists and your Gantt charts and so forth are perfectly fine, but that's not the norm. You're typically going to have some uncertainty. So on top of this type of thing, you're either going to maybe use multiple trials or iterate and learn at least on certain subsets or sub-projects of the project. But it's not an all or nothing possibility. You can combine them. So you can use the power of multiple trials in order to speed the time, but combine that with iterate and learn in order to reduce the cost. So you can kind of get the best of both worlds here, but again, it can be challenging and a little more costly to do this type of thing, but it may cut down on your time to market. So you can actually combine these two things in an exploratory type of technique in order to learn as quickly as possible, but reduce the cost. Okay, the final topic is this concept of thinking about project management tools as an approach to risk management, and that's an important concept because hopefully one of the most important things that you've gotten both in part 1 and part 2 is that you can't just arbitrarily go to a particular tool that you've used in the past whenever you start a new project. You really need to think about the risk within the project first and then pick the tools that are appropriate. So that's really one of the overall arching key messages of these last two webinars, is that you really need to step back, and rather than rushing to the tool that you're most comfortable with, you need to think about it in the context of risk. So there are three things that I'm going to talk about today. The first two really I'm just going to mention, not get into detail. I really want to focus on this last one. But Gantt charts are obviously a very common part of what we do. However, if you are going to use a Gantt chart to create a project schedule, I like the critical chain technique. And this is a great tool if you're faced with normal task variation, but that's just not the norm in most projects. So I don't think in the vast majority of projects that's the only tool that you're going to use, and you have to be careful a little bit about jumping right to that tool. And then Scrum for software development, which actually is a nice lead into the final topic today. So let's talk about this concept of critical chain. When you develop a Gantt chart, this is the common practice. You go to each team member, you estimate the task lengths, and you create a schedule. The problem is that every task has safety built into it, because people want to build a little safety and they don't want to disappoint. But the problem is they don't start the task on time, and then they wait a couple weeks because they think they've got a buffer in there, and then Murphy's Law kicks in, and then every task is late. Critical chain schedules creates a Gantt chart a little bit differently. You base your task lengths on the 50% probability that you will achieve that task. So 50% of the time you will go over, 50% of the time you'll come under, and then you create project buffers that are based on 50% of those task lengths. So you do that with the critical path, and you do it also with the feeding tasks. I like this technique for creating a Gantt chart. I think you have a much greater probability of coming in under the project rather than going over on the schedule. I think in this case you have no hope really in most cases of coming in under schedule. Here you do have a chance of doing that. So again, if your project is strictly task variation, then this is a good tool. It's rarely the case, but if you are going to use a Gantt chart, this is what my suggestion is. Second point I want to make, or second tool, is the concept of Scrum. And Scrum is used primarily in the software development field. It really is an application of iterate and learn to deal with the uncertainty associated with software development. So it's another great example of the use of these learning cycles for ferreting out uncertainty. And in software development, it gets back to the concept that we really don't know what the customer wants. So rather than creating an all-encompassing product specification, we come up with a product backlog that based on what are called user stories. We then pick off the highest priority ones of this product backlog, and then we iterate and learn. We have a team that iterates on that, on those features. We code it, we test it, we get feedback, and then we go back and forth through these iterate and learn cycles until the product emerges out of this process. So it's again a perfect example of the use of iterate and learn, even though it really is not billed that way. It's called the agile process or the Scrum process, but it's really fundamentally at its core based on iterate and learn. Now, some of these features of Scrum in particular are incorporated in this concept of this lean project management tool that I want to spend the rest of our time with. So there are two key features of this tool. One is the concept of frequent stand-up meetings in combination with what's called a visual project board, something that's located out in the team area. So these are the two key features of this, and we're going to go into some detail about these two features and how it's used. This is a great resource for you if you're interested in learning more. This is really my adaptation of what this author describes in his book. So we're going to talk about that, but before we do, I want to relate it to phase gate. Phase gate is a very common tool used in industry. It consists of multiple phases, and each phase has some high-level deliverables. For instance, in the scouting phase, for instance, it is probably going to consist of the marketing documentation for the project. It might include some patent searches and maybe some scouting of basic technologies and so forth. So You've got these multiple phases with high-level deliverables that are really going to drive the project schedule. And then you come to the business to get approval for each phase, and so there's a management oversight function where you get management approval to go from phase 1 to phase 2 and through the project. So it's a very common tool, but there's a key distinction between this tool, PhaseGate, and what we're really going to talk about, and that is that this tool, PhaseGate, is really an overall governance tool for looking at managing a portfolio of projects. It's not a project management tool, and I think in my experience a lot of organizations mix that up. So it's a very powerful tool for managing a high-level deliverables of the project and providing institutionalizing a management overview of the project, but it doesn't really tell the project manager how to run the project. That's really based on the risk and is very context specific. Now you can perfectly incorporate this lean project management tool into the overall framework of PhaseGate. In fact, the next webinar will really be on PhaseGate, lean PhaseGate process that incorporates this lean project management tool. So there's nothing that precludes you from doing that. It's just that it's really PhaseGate is not a project management tool. So you don't have to replace your PhaseGate process. You can actually integrate different tools into PhaseGate, whether it's the lean project management tool, or if you're using Scrum for a software development, or if you have a very simple project and you're using a Gantt chart with critical chain. Those all fit perfectly well into this concept of PhaseGate. Okay, so let's come back to this lean tool, and first of all, let's talk about the basics of these stand-up meetings. That is a key feature. These meetings are meant to answer 3 questions by every team member. What have you done basically since the last meeting? What are you going to get done by the next meeting? And what's blocking you from getting that done? Those are 3 key questions that every team member has to answer at these stand-up meetings. You keep them short. They're not meant to be long, drawn-out meetings, about 15 minutes. You don't want a lot of people in it. I mean, if you get 25, 50 people in a stand-up meeting, that's just not going to work. So you need to keep it small. You might have multiple meetings. Say, for instance, the engineering team might have their own stand-up meeting apart from the manufacturing team, and then the project manager needs to integrate that learning across the entire project. There might even be separate stand-up meetings for certain subsets of the project. So you want to keep it small. The cadence, how often you do these, is really going to be based on the project. Now, normally it might be 3 times a week, probably seems right, but it may be that at the beginning of the project it's not 3 times, maybe it's once a week, maybe it's not even started until after some time as the project starts to unfold. As you get closer to the end of the project, it might have to be done daily. If you're in a crisis, maybe even multiple times a day. So the cadence is really going to be based on the project. But overall, I think probably when you're in the meat of the project, so to speak, it's probably about 3 times a day. Now, the other important point here is that these stand-up meetings are not necessarily going to take the place of your normal say core team or project meetings. But the difference is that those meetings, in my experience anyway, outside of the context of using this lean tool, is that those meetings tend to have 2 different topics. One are more strategic type topics, and the other are task-driven type topics. So the idea is these stand-up meetings are really task-oriented. They're focused on the tasks. So you can pull that out of your normal project meetings, and now your project meetings maybe once a week or once a month are the core team, and those are really high-level strategic type things. They're not really day-to-day management of the project. So I think that's a key distinction here. The second aspect of this tool is this concept of visual project board, and that's used in conjunction with these stand-up meetings. It's going to be something that's probably on a big board out in the common area where you're having these meetings, like a 4x6 type of 4 foot by 6 foot type of project board. And so we're going to go through these 4 key sections: planned work, unplanned work. Really the heart of this is the 2-week action plan, and then this project timeline. I'm going to come back to the parking lot when I kind of pull it all together and kind of give an example of how this might be used in an actual daily meeting. So let's talk about these 4 sections, and let's first of all talk about this concept of this part of the board, which is planned work. So as I mentioned a few slides ago, in my experience, you start with a high-level block diagram concept. You start to look at your phase gate and your high-level deliverables, and then looking at the specific project and coming up maybe with a high-level Gantt chart with these big blocks of time and identifying the critical path. And that really is starting to drive the overall tasks within the project, these big high-level deliverables. And so the concept here is you take this overall project Gantt chart, for instance, and you hone down into maybe a 2-month window. Now, it depends on the scope of your project. If you've got a, say a 2 or 3 year project, then maybe a 2-month window is appropriate. If you've got a 6-month project, well, maybe a 1-month window. So you're going to hone down on a specific subset of the project, that window into the project that you're really focused on right now. And rather than in a Gantt chart form, it's just in a simple Excel spreadsheet type of form, but it's high-level deliverables. These are not really specific tasks, they're high-level deliverables. So a prototype deliverable, it's going to be somebody that's responsible, when it needs to be done based on the overall master schedule and an actual completion date. And then you got some status columns here. You can kind of morph and change this to fit the project, but here you got cost and schedule and technical status. You can use some really simple graphical elements to indicate that things are okay, things are cautionary, or you got some crisis, and then a comment section. So it's a really quick way in the project stand-up meeting to quickly illustrate where the project's problems are. And it's really meant for information purposes. So that's the planned work section of this of the project board. The unplanned work is, how it goes, and if you've ever managed a project, there are things that come up that you don't anticipate. That's just the nature of project work. So the concept of unplanned work are things that come in that you had not planned for, but they have to be accounted for, again, in a kind of a rolling window type of format. And you can have a little bit different format here: responsibility, due date, completion dates, maybe some color coding to indicate that where the problems are, priority, etc. So again, this is at least a place to start, but you can modify it to figure out what works best for you. The third kind of key part of the board, and really the heart of this concept, is the center section of that visual board and the 2-week action plan. So again, you start with your high-level project schedule that goes from the beginning to the end. In the previous 2 slides, you hone in on maybe a 2-month window, and now you're going to hone in further on 2-week tasks. So these are the actual tasks that are really important in terms of driving the project forward. And this consists of the key team members over a 2-week period. Let's say these are sticky notes that define the tasks. You can use some color coding, say red for high priority, blue for lower priority, yellow for lowest priority, or whatever. The white maybe is unplanned work, or that particular team member is out of the office. So this is what's going to drive your actual stand-up meeting, the discussion around these actual tasks. And it's really the responsibility of the team members to come up with these tasks based on the deliverables that they're working on. It's really only the team members that can really pull those things apart and figure out what the tasks are. And it requires those team members to do that. Maybe before this particular person, maybe all these tasks are related to a designing of a printed circuit board. Well, you got to break that down. Sometimes engineers don't like to do that, but that's what this method relies on, is getting people to think about how to break tasks down, how to break their workflow down. That's really a key aspect of this. So let's look at the particular stickies. They're very simple: a responsible team member, the date that they need to be completed, and a basic description of what that task is. That's all it is. Okay, the fourth kind of section up on the right corner of that board is a project timeline. Now this is a nice graphical, quick way to communicate to the project team or anybody else that's coming by and looking at the board, management or so forth, where you are on the project. And the idea here is to identify the critical path milestones. Now this is just indicated in numbers. Again, this can be a rolling window. It doesn't have to necessarily go from the beginning to the end of the project. But the idea is you identify those critical path milestones. You've got cumulative dates here, and when those milestones are planned to be finished, and then the red curve is actually where you are right now. So, it's a very easy thing to look at where you are in as far as variance. So you can see right now, let's say here, you've got a variance in the project. Now it's tracking along fairly well, but if the red line was tracking further apart than the blue line, then you got a real problem in the project. So it's a very quick way to illustrate where you are with the project. Okay, so now let's put it all together here, and let's use this concept of the project board in concert with this project meeting to try to illustrate what might happen at a meeting like this. So let's say it's Monday morning, and let's say that Nancy is the project team leader. So she kicks off the meeting, maybe it's 8 o'clock in the morning on Monday, and she starts with Tom. And she asks Tom to describe what he's done since the last meeting. Presumably, since it's Monday morning, excuse me, this task should be done. So Tom's going to talk about that, and if it is done, he's going to remove that sticky note and hand it to Nancy. Now Nancy can actually incorporate these into maybe a project book, which is a good way to kind of track the initial estimates of a task versus when the task gets completed. So she starts to get a feel for how accurate people are in terms of estimating their tasks. So anyway, if it's done, he removes it and hands it to her. If it's not complete, he needs to talk about that and move it to another date, or maybe move it to another task member, whatever. So he might have some new tasks that he needs to add, so he's going to talk about what he's done since the last meeting, what he needs to get done over the next few days, and anything that's hindering him from getting that done. So that's the first part. Note that the priority here on these tasks is really going to be driven by the team member, but it can be something that can be discussed within the context of the stand-up meeting. So once Nancy is finished with Tom and the group has their quick discussion, she moves on to Frank and on down quickly through the other team members. So that's what's going to happen on Monday morning. There are some key kind of procedural items. First of all, at the end of that meeting, this column needs to be cleared. Nothing should remain on that column because presumably when they set that up, that was the date. It either has to be moved because the date's going to be later. Maybe it gets eliminated. I mean, and I guess in a rare case, there might be a task that was on somebody's list, but because of something else, maybe the task is not required. So you have to move it to a later date, remove it, maybe move it to another team member. There are only 2 or 3 things that can happen to those tasks, but it all has to be cleared at the end of that meeting. Secondly, during that discussion, there are probably going to be a lot of off-topic things that come up. And so that's the concept of the parking lot, that when you're talking through these tasks on the 2-week action plan, if something comes up that's off topic but you want to collect it and think about it, you can put it in the parking lot. Maybe at the end of the normal 15-minute meeting, a couple of team members stay back and they talk about that issue. The rest of the team members can go back and do what they need to do. So you can, that's kind of a third aspect. You can kind of carry on and have a discussion after the rest of the team members leave. The final thing is that it's important not to modify these tasks until the next meeting, because everyone's kind of leaving that meeting with a perception of what's happening, and you don't want to change it between meetings. You only make the changes at the stand-up meeting. Okay, so that's the essence of the Lean project management tool. I think there are some really key advantages. First of all, I mentioned it before, most projects in my experience are not strictly driven by task variation. That means detailed, very highly granular Gantt charts are not always the best tool. You know, we tend to focus on that because it's an easy tool, it's a common tool, but it's not always the best tool because you really always will have some level of unknown unknown. So I think other than for the simplest projects, Gantt charts are not going to be your main tool. I think this Lean tool is better. Now you can incorporate, you know, individual team members might have specific, very highly detailed Gantt charts for their piece, and that probably is the way to do that because that really forces it down to the team member in terms of really understanding, you know, how to get to the end date and really understand how to line up these the tasks. Secondly, it really focuses on the team's day-to-day activities, and I think that's really, really important. It's really focused on what you have to do today and keeps the pressure on the team to focus on those tasks. It's really, this is really where the rubber hits the road, so to speak, in terms of getting the day-to-day stuff done. A key thing is it breaks workflow into smaller chunks, as I mentioned before. Really, that's a key aspect of this concept of flow through a process. So it's the same thing we talk about in manufacturing with flow, and the way that you achieve flow is to break workflow into smaller chunks and get faster feedback, and that's really this concept of more frequent short meetings speeds the feedback in the loop. So all of these things really help break workflow into smaller chunks, faster feedback. You don't have to wait until the weekly project meeting to resolve some type of an issue or rely on the fact that somebody bumps into one another in the hallway. This is really a great way to do that. As I mentioned before, you can also still have your periodic core team meetings, but these really become strictly strategic. You're not going to use these core team or team meetings to drive the project in terms of task management. That's, I think, a key aspect is it breaks out the task management into this concept, and then you keep these core team meetings really for more strategic type issues. The final thing I want to talk about is this relationship between project planning and managing the project or task management. There's really two things going on here. You know, what we talked about before in terms of creating your high-level block diagram or your design, coming up with your initial schedule, using, you know, risk lists to ferret out your foreseeable uncertainty, and then your iterate and learn concepts, your knowledge briefs to drive the learning on the unknown unknowns and all of this that's going on. This is really project planning. It's really all meant to break the project down and understand how to get to the tasks, and then this Lean tool is really a task management tool. So there's a difference between project planning and task management, and that's really what we're talking about with this Lean project management tool, and that's how they kind of interact. It's probably a two-headed arrow here in terms of, you know, as things happen here, it feeds back into this as well, but you know, this is an important, I think, distinction. Okay, so in summary, if we go back to part one and part two, I introduced you to this generalized approach to risk management and mitigation, and that's the risk matrix. I think it's a very important mental model that you need to have in mind. You need to start with that concept whenever you start a project, and I think it's an important thing to kind of keep in the back of your mind in terms of understanding these sources of uncertainty and how it plays out, and how you have to understand where the pieces of the project are within that matrix in order to pick the right tool. I introduced you to the concept of the MPD risk assessor. That's a quantitative business risk tool. I think it's a great tool if you want to try to quantify risk within the project. Gantt charts using the critical chain technique. That's a very good technique when you know what the tasks are and really you're managing task variation. So that's where critical or where Gantt charts really come into play is, where you have known tasks and you're just managing task variation. On top of that, if you've got foreseeable uncertainty, then you're going to use things like risk lists and FMEA. That's what these tools are all about, is trying to manage and mitigate foreseeable uncertainty. And it's really out of this analysis that you're going to identify these knowledge gaps that might point you in the direction that you've got unknown unknowns. If you've, on top of foreseeable uncertainty, have complexity, then you really have to think about this mindset of control and fast response, this concept of trying to get the system to fail and to not simplify when there is a failure. So it's really more of a mindset versus a specific tool. And it's really inherent on the project manager to exemplify this mindset within the project. And then, on top of that, if you've got task variation, foreseeable uncertainty, complexity, then if you've got unknown unknowns on top of all that, then you're going to be focusing on these concepts of iterate and learn in parallel trials to ferret out these unknown unknowns. And bear in mind that complexity in and of itself can lead to unknown unknowns. And of course, I mentioned the fact that the scrum is really an application of iterate and learn specific to software development. And finally, I think this lean project management tool that we finished up with is really a good overall project management tool for managing the tasks, for managing the project and the tasks in general for most projects. And again, I'll mention, that if you're only faced with task variation, then Gantt chart can certainly be a good tool, and you can incorporate Gantt charts into the overall concept of your project. Okay, I want to thank you for attending this month's webinar, and we look forward to your participation next month. Have a great day.